Hello, I'm Elecia White, and this is Embedded. My co-host is Christopher White, and our guest this week is Derek Fronek, who will be telling us about FIRST Robotics, what it's like competing, and how you might get involved.
Hi, Derek. It's nice to talk to you today.
Hello.
Could you tell us a bit about yourself?
Yeah, so I'm a senior at Carmel High School in Indiana. I'm the robotics design lead on a robotics team, the TechHOUNDS. And I've spent all 4 years of my high school career on the team, and hopefully in the future plan to go into electrical engineering at Purdue.
All right. And I know you have heard the show a few times, and so you already know about Lightning Round, and we're going to skip straight to it.
All right.
What's your favorite class?
My favorite class, digital electronics.
What's one thing you were surprised to learn in the last year?
That companies selling out of products can be a bigger issue than you think.
Hardware or software?
Hardware.
Most exciting science fiction concept you think will be real in your lifetime?
Flying cars.
What's a tip you think everyone should know?
I tip everyone should know. Don't order your PCBs as soon as you finish designing them.
How long should you wait?
Give it a night at least, and then look it over one more time. I have a whole drawer full of failed ones because of that.
Favorite fictional robot?
R2-D2.
You don't have to be sad about that. That's the right answer.
Yeah, it really is.
Favorite animal?
Sky bison.
Some people will get that.
Hopefully.
Yeah. And at what age are people old?
Hey.
It's just his opinion.
People get old when they stop being able to do everything they were able to do earlier in life.
So 20.
Yeah, that's like 20. Good luck.
Yeah, here comes the youth opinion of when people get old.
Okay, tell me about TechHOUNDS.
Yeah, so TechHOUNDS is a robotics team in Carmel High School. It competes in FRC, which is First Robotics Competition. It's a subsidiary of FIRST, which stands for the Inspiration Recognition of Science and Technology. It's a large competition of thousands of different teams throughout the world that are given a game, and we design a robot based on the game's parameters and then compete in competitions in the earlier part of the year.
And there are different levels to FIRST. I mean, this is the high school version, but there are other competition areas? Yes.
So FIRST prides itself on having competitions through all levels of primary and high school. So they start off with FLL Junior, which is FIRST Lego League, which is for younger kindergarten, elementary school kids. And then they have a regular FLL League, which is upwards later elementary school through middle school. And then what they have is called FTC, which is First Tech Challenge. It's essentially kind of a scaled down version of FRC. So you're still this one, you're actually building robots with manufactured parts or VEX parts or some kind of material as opposed to Legos. And then once you get into high school, you can compete in FRC, which is the largest scale that FIRST offers.
And by large, I mean, these were 120-pound robots.
Wow.
Yeah. The robots, generally every year, it's roughly 120 pounds. There are obviously dimensional constraints that we have to work around. Year to year, it changes based on the game. So a couple years ago, we had to create a robot that was less than like 30 something inches. And then this year, our robot, since the game involved moving objects to 7 or 8 feet, our robot had a large elevator, and in its lowest position, it was still 5 feet tall. So they vary from year to year.
Okay, so you talk about these games, and if I understand correctly, like the first league in January says, okay, here's the game, you have 6 weeks.
Essentially, that's the gist of in January, the first week of January, generally they have a live stream event where they present the game and they release the game manual that gives you all the information that you need to be able to design around what the game objects and obstacles in the game. And then you have a very consistent rule book on what can and cannot be on your robot. And then you are just given. You can do whatever you want at that point, and it's your team's decision how you're going to play the game.
Okay, and so the 2018 game, you said, involved an elevator and moving things. Tell me more about the 2018 game.
Yeah, so the 2018 game, this year is called Power Up. It was an 8-bit video game theme, so they're like power cubes, kind of like Pac-Man pellets or something like that. And the game essentially can be described as teeter-totters almost, where the crates, which are essentially milk crates, they just have like a wrapper around them. The goal of the game is to be able to tilt the scale in your favor. There's 3 sets of scales, 2 short scales and 1 large scale in the middle. And then if you control the scale, you earn 1 point per second for as long as you control the scale, as well as cubes can also be placed in what's called the exchange, which can then be used to earn power-ups to like boost your score for 10 seconds so you get double points, or force control of the scale. So even if the opponent team has control of the scale, you take control of the scale for 10 seconds. So it adds a little bit of strategy to the game.
Okay, so you have how many teams playing on the field at once?
So the teams are broken up into 2 alliances, one on each side, consisting of 3 robots. So there's 3 teams per side for a total of 6 robots on the field.
Okay, and then there are 3 different scales, and you want to control the scales, and you want to take your milk crates to the scales, to certain other places?
The main objective is to the scale. So you basically want to have more crates than the other team, so yours weighs down and tilts in your favor. So that's when you start earning points. And then there's also the exchange where you put cubes in, and then it's up to you when you want to use those power-ups during the game to give you kind of an advantage.
So you're working with different teams. How long do you have to coordinate with these other teams?
So generally, it's a pretty limited time frame of when at the competition. Usually, the night before the matches start, they'll release the schedule, and you'll know what teams you'll be playing with. So generally, that first night and the day in the morning of the competition, you'll see people going around through the pits with a spreadsheet and taking pictures and writing down information about what every team can do, so you can plan ahead.
Not a lot of time.
There's not a lot of time, so you can't really like design your robot during build season with another team for the intention of working with them.
And back to the 6 weeks. You have 6 weeks to write all of the hardware, or write all the software for this. Do you get a base model robot? Do you have to design a whole robot in 6 weeks? How does the 6 weeks work with the hardware part of it?
So with the hardware part, I was going to say, software would love if they got 6 weeks to actually work on drive on the hardware, but that usually gets pushed to the very end, unfortunately. But for the hardware, they do offer what is called a kit bot, which essentially for rookie and newer teams, they offer essentially just a drivetrain that you can have as a frame, so you can kind of build off of that. So it doesn't make the learning curve as hard to get started into the team or into the game, but we build everything from scratch. We design our own drivetrains, and we design most of our gearboxes are off the shelf. But other than that, we design all the mechanisms ourselves within those 6 weeks.
Within those 6 weeks, so this isn't. I got the idea this was like a year-round thing where you essentially make little. I want to say Lego blocks, but that's not right. Make interchangeable parts or multiple different kinds of robots, one of which might meet the specifications this year.
No, you design and build your entire robot within that time frame of 6 weeks. So it's an incredible stress on limited amount of time. But there are rules about what you can use that you've kind of have left over, or designs that you have from the previous season or that you designed in the off season. Generally, if you release all your information about your designs and make it open source, you're able to reuse those designs. You're not supposed to reuse physical hardware, like a mechanism that you designed. You're not really supposed to reuse those unless they're what is called COTS, which is off-the-shelf parts from manufacturers. You're allowed to reuse those and keep those in stock, like motors, some gearboxes, if you didn't design the gearboxes yourself.
How do you draw the line? I mean, you could buy an exceedingly expensive robot to do all of this.
Yes, so there is a price limit on the amount of material that can be on your robot. So the limit is generally every year it's around $4,000 per robot of non-COTS parts. So if it's listed as a COTS part or you bought it from a manufacturer, it doesn't count against that $4,000. So it's kind of, your robot could be more than $4,000 money you actually spent, but on the official document, it won't be over $4,000.
The whole robot could be COTS.
Essentially, yes, but I mean that doesn't really happen because people obviously design their own mechanisms because they need to be tailored to the game. But in theory, yes, it's a unusual circumstance. So
it's an unusual budgeting method. That you can buy things. You can go to the store and buy whatever you want, but if you make it, it has to cost less than this. This is like the opposite of reality.
Yeah, it's very unusual. It's a very unusual thing that it doesn't usually cause anyone trouble. That there is I do remember there is a stipulation on buying parts. No single part can cost more than $500 that you buy off the shelf. So no single part can.
So you really couldn't buy the whole robot.
As a single unit, no. You could buy, all the individual parts, I suppose. But yeah, you couldn't buy it as a whole.
So you get the game. You have 6 weeks. You aren't supposed to have much in stock other than raw components like motors and maybe an off-the-shelf motor controller board.
Yeah, or some designs you've released publicly that everyone can then build themselves. So that's the kind of idea of iterating over the preseason.
Yeah. And then you just don't sleep for 6 weeks? Do you fail your classes? How do you eat? I mean, I'm just like, okay, if you gave me that in 6 weeks and a team of 5 reasonably competent engineers, maybe?
No, you have it pretty much right. I don't sleep. I don't eat all the time, and school is an incredibly stressful event, especially for those who really put all their effort into this. It forces you to learn how to organize your time as efficiently as possible. You have to be able to maximize every second of the day so you can then go back and continue to work on your robot.
Do you have classes? I mean, does doing this count as part of a class? You mentioned you had a design electronics class.
Yes. So until actually this year at my high school, other high schools do have classes. Up until this year, we never actually had a class. This year, we actually have created what's called we call it robotics design and innovation. So it is a class where essentially it's a only usually people on the robotics team can join, and it's basically focused on learning new elements of design, and then during the build season having that time completely dedicated to building the robot.
So this takes a lot of time, especially during those 6 weeks. How much does it take outside of those 6 weeks? How much do you do?
So outside of those 6 weeks, immediately after the build season is completed, it transitions to what is called competition season. So during that period of time, from about early March to the end of April, is where you have your competitions. So generally, there are competitions every week. Most teams don't go to a competition every week. Generally, if you're in a district system, you're in 3 to 4 competitions plus a state and possibly a Worlds if you qualify. Other states are in what's called a regional. So there are several large regionals that you would go to. So you don't get as many matches if you're in a regional system. But yeah, that's what happens immediately after build season. And that's also a very time-consuming event.
How much design happens during competition?
So generally, most teams do spend a significant amount of time modifying their robot during competition, or then taking whatever lessons they've learned from competitions and then iterating their design after they've had competitions to try to improve, be better than the next one. Although there is a stipulation on this. Between competitions, your robot has to be what's called bagged. So you do take a very large plastic bag and you bag it and tag it. So there's a tag that identifies, then it has a serial number so they can keep track of when your robot's been unbagged. But the week of a competition, you have 6 hours to unbag and make any modifications before you actually arrive at the competition.
So do you have a second robot you use?
Yeah. So this year is the first year in many years that we actually did build a second practice robot. So it's as a perfect representation or a perfect copy as we could possibly make it. Obviously, since it's the second one, it doesn't get as many of the nice touches and perfect construction as the real one, but it's as close as possible given the time frame.
How much does the main robot get beaten up?
Generally through competitions, it is a very rigorous time, especially for
rigorous. I think that word means crashed, burned, small parts flew everywhere.
or large ones. Generally this year, we did have several events where we break some major part of our robot, and next thing you know, we have 5 minutes to fix it, and if we don't fix it, we don't win. That's happened 3 times during finals, during competitions, where so on our robot, we have what is called an intake. So essentially, it's 2 arms that have roller wheels on it intended to grab and intake those cubes into our robot. So it's essentially like rubbery wheels that pull the cube into the robot. And that was the biggest point of failure / iteration on our robot. From the first competition, we sustained it originally was designed out of 16th inch 6061 aluminum. The unfortunate thing about that is it has fairly decent strength, but once it deforms, it doesn't return to its original shape. So over the course of the competition, through numerous impacts with other robots in the field, we ended up shattering those intakes. Of course, it had to be during the finals. So we were frantically working on putting that robot back together. We ended up having to use basically what is L bracket, like 1/4-inch L bracket, and then using basically as a splint to hold the arm on through that competition. Thankfully, it worked, and we ended up winning the competition, but it was a very frantic time.
So this is a good opportunity, since you mentioned some of the parts of the design. What does this robot look like from a hardware and software standpoint? What are you using for boards, and what kind of software is running on?
Operating system, Pi. Yeah.
Just walk us through the entire design so that we could copy you and
electronics specifically right now?
Yeah.
Okay.
Sure.
So to make life a little bit easier for the teams who, don't have a legion, they're all high school students and they don't have a legion of electronics design engineers on the teams. They do provide off-the-shelf mandatory electronic components. So these consist of the RoboRio, which is essentially the main processor on the robot. It's a National Instruments, one of their industrial controllers. So it's got like an ARM CPU in it, an FPGA for all the I/O control, and then it runs some kind of real-time Linux OS.
Okay.
And then on the heavier side, current carrying capacity, there's a power distribution board, which is essentially equivalent to a breaker box in a car. It contains all the main breakers. They're self-resetting breakers for all the individual motors on the robot. So if you blow a breaker, then it'll self-reset, so you don't have to worry about that. Generally, they're about 40 amps is the biggest they go on the 40 amps per motor or per port on the power distribution system. And then there's a 120 amp just automotive thermal breaker on the main input of the battery. So that won't reset itself. You have to manually reset that. So if you blow that breaker, you're done, which has happened before. And then motor controllers, there are quite a few actually off-the-shelf motor controller options. One of the most popular in recent years has been the Talon SRX. It's made by Across the Road Electronics. It's essentially a motor controller. They call it a smart motor controller because it has an onboard microcontroller and it communicates over a CAN bus, kind of like an automotive CAN bus. It has built-in I/O for sensor feedback encoders and limit switches. I know this because I've designed boards for that, breakout boards for I/O expansion. But it also has PID features for motion profiling, for software, motion profiling, and some other niceties. It's a fairly nice system. And then there are more simplistic, just PWM-based controllers. There's the Spark motor controller. I believe it's made by Rev Robotics. A lot of these companies design specifically for FRC competitions. And it's just a basic PWM controller that you just give it a PWM duty cycle, and then it will drive that motor based on that. And they do have what is called brake and coast on that. That's the only other feature it has, which essentially stalls the motor in brake mode and lets it just wind down naturally in coast. And those are the main. There are some other components for pneumatics, air pneumatics. It's just called a pneumatics control module, and that also communicates over the CAN bus. And then there's one more. It's just a voltage regulator. So it's a 12 volt to 5 volt DC to DC converter.
So this is a lot of electronics. I mean, there's actually a lot more electronics here than I expected, and many of them are made for this competition.
Yes.
But that's also what you do. What kind of boards are you making, and how are you making them in 6 weeks?
So I don't usually actually make those boards in 6 weeks. That's one of the benefits of being able to release it open source. You can design them and use them in preseason and then use them in your competition season.
You seed yourself with.
Yeah.
And as long as you make sure everyone else has the information to make them, then you can make them yourselves. So major things we've used in the past, a couple of years ago, the electronics lead, I think, 2015, he designed an I/O expansion for the Talon. Basically, the Talon's I/O for encoders. It's a 2x5 0.05 millimeter pitch pin headers, so they're very inaccessible to standard, breadboard cables and stuff like that. So we designed a breakout, which essentially breaks out all the ports to that, which is standard 0.1 or 0.1 inch pitch headers, and then I redesigned it in the last year to add I/O visual feedback on it. So any sensor you have plugged into it, if you trip like a limit switch or an optical switch, it gives you visual feedback with a LED that tells you, hey, this switch is working, which is incredibly vital when you have limited amounts of time to maintain your robot. If you can just simply put your hand in front of an IR limit distance switch or something and just see the light go on and off, then you can just kind of move on and you don't have to go into the operating system and check all the sensors individually. So that gives you incredible amount of, it makes life easier to test and maintain your robot in the field.
Test and maintain your robot in the field. Wow. I'm just like, I can't believe you're doing this in 6 weeks. I can't believe you're doing this in high school.
Yeah, it's an incredible opportunity for high school students to get into. And one of the great things about FIRST is the fact that it's not just high school students. We rely heavily on the advice and the mentoring from adults and engineers alike.
And it's also younger kids, and the advice and mentoring, it doesn't always have to be technical, does it? Because there's a lot more that goes on here than the hardware and software and mechanical.
Yeah, FIRST prides itself on it. Basically, you come for the robots, but you get a wholesome life experience out of it. So you don't just do engineering. You do volunteering, and you have to raise funds because obviously these robots are nowhere near inexpensive. So fundraising is a huge part of what we do, as well as community outreach. We have numerous community outreach events that we try to engage more people in STEM-related activities.
Okay, I'm totally for those. How does that relate to the FIRST Robotics? I mean, how does outreach... It seems like FIRST Robotics is the outreach. What are you reaching out? Help?
Yes. So during competitions, there are awards at the end of competitions, and the awards equal points for essentially what's happening is the end goal is being able to get to the world competition, which in the last few years has been located in Detroit and Houston. And so essentially in your district, at least in a district competitions, you earn points, and then essentially the one who has the most points based off if you win, if you earn these awards, then can qualify for the world championships. Outreach is a huge part of this. They really emphasize reaching out and engaging more people in STEM. So outreach awards, which is called the Chairman's Award, at district and state competitions, can earn you direct admittance into world competitions. So that's one of the things they kind of do to motivate teams to reach out into the community. And
so what do you do? What sort of activities do you do that count under that?
So activities that we do as TechHOUNDS, I don't speak for all the other teams, but we do personally. So during off season, we host in the October, we host what's called the Women in Technology Workshop, which is essentially we have roughly 70 to 80 middle school girls from the middle schools in the surrounding area. And we have them over for a day where we teach them STEM activities like CADing or physics and other STEM related activities, and try to engage them and get them excited to get into STEM careers in the future. That's one of the things we do.
How do you organize that? I mean, I know you do a lot of the double E stuff. How involved are you personally with the outreach and the fundraising and all of the coordination bits?
So the outreach, I generally do attend about every outreach event and help out with the actual running of the events. With all the time I'm spending with the engineering aspect of the team, I don't really have an incredible amount in planning the events and organizing all the speakers that we have come and all the different logistics of food and materials and all that. But I do just try to help out any way I can in running the events.
But TechHOUNDS is pretty big. You don't have to do it all.
No. Our team is generally anywhere between 80 to 115 members. We are an exceptionally large team. Most teams are in the 20 to 50 range, but we are exceptionally large because our high school is this year, I believe the total amount of people in the high school is 5,300. So we have a large pool of people to draw from.
And when I saw the picture of the TechHOUNDS team, it looks like you had all kinds of people.
Yeah, we encourage everyone to join, no matter who they are. we pride ourselves in trying to be as diverse as possible. So anyone from all backgrounds is welcome to join the team. We try to occasionally have some younger kids come out and experience what the team is so they can get into in the future, as well as we have adult mentors.
One of the challenges with engineering mentality in professional world is that it's easy to assume that your discipline is the most difficult. Even easy to assume that you are the hardest working because you don't see the hours other people put in because you're working. Does that happen on your team? And how do you try to avoid assuming you're the best?
Yeah, that definitely does happen. There is some kind of favoritism, I guess. People kind of see robot ops as, that's what we call our robot building division, as since we kind of build the most physical representation, kind of outgoing mechanism on the team, that kind of gets the stigma that we are the more important division. But we do try to kind of put that down and emphasize that everyone is having making a positive impact on the team. So we have several different divisions focused on doing different aspects of running the team.
What are the divisions?
Yeah, so on our team, we have, as I said before, we have what's called Robot Ops, which focuses on the mechanical design and implementation of different mechanisms into culminating in the actual robot. And then there is programming, which is focused on programming the software specifically for the mechanical robot. We also have IT, which does website design, as well as the scouting system, which is in competitions. We scout different teams during matches. So we'll have 6 individuals on laptops recording everything every team does during the matches, so we can keep up with what's going on, so we can know in the future how they're going to perform. And then do a lot
of teams do that?
Yes, almost every team who is highly competitive has scouts in the stands, writing down as much information about these teams as possible, because it is critical to know how other robots are performing in order to make informed decisions and who your alliance members for the tournament actually is. So it's incredibly important that you have all that information available to you. And then for other divisions, we have electrical division, which focuses on implementing the electronics onto the mechanical design. Robot ops and electrical we try to kind of work together as efficiently as possible, because obviously the hardware and electrical implementation needs to be fluid, so we don't have a mismatch and we can't implement as many features as we want. And then there is what we have construction, which focuses primarily in building. So once we get the game information, they release all aspects, design drawings, so you can build your own field. So that division focuses on primarily building field elements, so we have those to practice with, as well as building a lot of the carts and tool chests that we bring to the competitions. So we built all our own tool chests and battery boxes in order to bring those to competitions, so we have a mobile platform, so we can just roll it out of the trailer and roll it into the competition. And then finally, there is PR, public relations. They focus on creating a positive image for the team, as well as organizing all the fundraising and outreach events that we have on the team.
So you have a complete company.
They really do. And just like our engineering companies, like everybody's like, oh, whoever's building the thing is the most important. And yet Derek said only a moment ago that you could get to finals with just outreach. So every team there is going to be so important.
Absolutely.
Wow. There really is a whole company.
Yeah, any company is incredibly difficult to manage. So it requires an immense amount of effort from everyone involved to be able to maintain and perform at the level we really want to perform.
Do you have dedicated kind of management people who don't necessarily do hands-on stuff, but are just coordinating all of this?
Generally, yeah. So we have division leads. So those guys those people are elected at the end of the year into those positions on a yearly basis. And those are in charge of their specific divisions, as well as we have an overarching team lead that focuses on organizing the team, like meetings and structure and keeping everyone coordinated, as well as PR is also focused on helping the team lead with those aspects, as well as coordinating outreach events and positive public image.
And these are all students. Not even the team lead is a faculty member.
The team lead is a student. There is a team coach. You have to have a team coach. Obviously, you have to have adult supervision and all that kind of stuff because we're all minors. But he does. Our team coach, he does spend a significant amount of time, and I cannot thank him enough for the efforts he puts in to allow us to do what we do, because otherwise we wouldn't be able to do it without him.
Okay, what do you get out of this?
So what I get out of it is, I guess, in short, would be the greatest experience of my life so far. But it has, from when I joined the team my freshman year, I've learned more than I ever could have possibly learned in any regular school setting. And I've engaged, and it's allowed me to kind of give me the passion for learning STEM and engineering. And now I have focused myself on a career going into engineering. So it's been a transformative experience for myself.
Do you plan to go to college?
Absolutely. Yeah, I plan to go, right now I'm looking at Purdue in Indiana, going to their electrical engineering college. And I think right now, based on what I've been doing and what I like doing, I know this is the embedded podcast, but I do actually want to go into embedded design. It just seems really interesting to me.
I mean, you're getting a huge view into what it's really like to be part of a company in this robotics. And so if you are enjoying it, then yes, you probably enjoy a career in embedded. And I'm thinking Purdue, and I'm thinking Chris Sveck is going, oh, come on, say me. I went to Purdue. I can introduce him to people. So, yeah, hi, Sveck. Anyway, that is awesome. That is so cool. You mentioned finals with respect to TechHOUNDS. How far did you guys go?
So this year was an exceptional year for the team. Our first competition, we attended a week 1 regional in Miami Valley, which is in suburbs of Cincinnati. Cincinnati. And we had an underwhelming competition. Going into that competition, we started with essentially an unfunctioning robot. I had a whole checklist of, we need to replace this, we need to change this out, we need to add new parts here. So we spent about 12 hours once we got to that competition making all the modifications that we needed to. And then in that competition, we didn't perform as well as we wanted to, but we recognized what the flaws of our robot were, which lied in the intake system. So we had 2 weeks till the next competition, and we spent that completely redesigning the entire intake system into something that has served us exceptionally well for the rest of the competition season. So going into the next competition, we competed at the Plainfield District event in Plainfield, Indiana. That event was a really amazing event for the team. We ended up winning the competition. That competition, as I was talking about earlier, where we had major failures with that intake system during the finals. So it was an incredibly stressful time because I had less than 2 minutes sitting next to the field, frantically bolting on splints to hold the intake together so it compete. Because specifically during that event, since the aluminum bent inwards on the intake design, it's driven by basically a drill motor driven into a 7-to-1 gearbox. The output stage is a belt and pulley. And since the metal bent inwards, the pulley lost all tension. So even if the motor was still spinning, there was no tension to translate the energy into the rest of the wheels. So we were frantically trying to rebend and use braces and clamps to try to bend it back into shape throughout the entire competition. But we were able to we had one of the sides working by the end of the competition, and we were still able to win it. So it was a fantastic event. And then we went into our second district competition, which was the Tippecanoe district event up in Lafayette, Indiana, basically at Purdue. It was at a high school nearby, Harrison High School, but that was also another exceptional event. We ended up winning the competition. It was a relatively frantic event. Not as many failures on our robot. We had to help other team members. Actually, it's a really great event because one of our alliance members that we picked was a rookie team. So they helped us win that competition. So it was a really great experience for that team. And we've kind of formed a great relationship with them after that. And then one more thing about that competition actually is a very good learning experience for myself, and hopefully this could be a tip for everyone else. If you're ever working with Lexan polycarbonate, do not put Loctite on it. It will shatter it. I learned that the hard way.
Good to know.
Yes.
Okay.
Yeah. So, and then another competition, we competed at the Indiana State event. We ended up winning that competition. It was an incredible event. We had some more frantic repairs that we had to make during finals, and then we moved to we qualified because of winning our competitions as well as state. If you win state, you automatically qualify to go to Worlds. At Worlds, it was probably one of the best experiences we've ever had. We ended up placing 5th in the world. We were incredibly close. We were one match away from going to the final competition at Ford Field, but we were unable to do so. But it was still an amazing experience, and I can't thank everyone on my team enough for being able to work with us on that, and being able to get as far as we did.
It's going to look so good on your college application.
Yeah, that's I have my essay written, and yeah, it gives me some really great learning points to write about for sure.
Yeah, those college application people really kind of lap it up when you say, "Oh yeah, I know how to win, I know how to succeed, but I also know how to fail." What was your college essay about?
I don't remember. I think I wrote a satire. It was very odd. I don't think I took it very seriously.
Yes.
So was this primarily where you've learned your electronics experience and where you got started with it, or were you interested before and already knew stuff? How did you get to this level, and was it mostly through FIRST, or was it other stuff too?
So I definitely say I did like some kind of electronics before I got into TechHOUNDS, but that was the key point where I dove into it to the extent that I have. I did learn a fair amount through FIRST, not necessarily because FRC, since there are a lot of off-the-shelf parts and you basically have a complete off-the-shelf solution for electronics, that didn't necessarily teach me the design aspect of it, but it gave me the will to be able to go and find that information myself. So a lot of the times I ended up using YouTubers and watching those and reading articles on how to design, as well as I have a mentor who's a retired Air Force engineer, and he's helped me greatly through designing different designs, and really been a great mentor to myself personally.
Well, that's a good lead into mentoring. You have mentioned this before, that you have mentors on the team, and that it's a volunteering opportunity for engineers or anybody, because all of your divisions need some help and people can get involved. How do they do that, and how much time are they committing?
So Yeah, the thing about mentoring for FRC, we welcome anyone to join. Generally, we meet people through contacts from parents, as well as we go to outreach events. We demonstrate at different companies, and we try to gain contacts through that, as well as people have found us online before. There's an entire complete listing of teams on First website, so you can look around to see if there's a local team near you that you can contact. But the time commitment is, at least on our team, it is fairly significant. So we welcome anyone, but we do try to recommend that you do have time, a decent amount of time. You can come in on a regular basis, because if you kind of start at you start day one, but you don't come back till 2 weeks in, things have progressed significantly. And it kind of, if you're out of the loop, you can still help out, but it does kind of create a disconnect where things don't always go as smoothly because people aren't always on the same page. But we welcome anyone who wants to join. But
that regular attendance is usually more during the 6 weeks of design and the 4 or 6 weeks of competition.
Yeah. Generally, yeah. The that time commitment is focused primarily during build season. During preseason, what we call preseason, from September to up until till competition or build season, we only have weekly meetings, so it's a much easier time commitment for people to make. And those are a lot of times we try to build those closer relationships that give people the kind of will to be able, or they want to get into it more because they've had this limited exposure. So we try to build those relationships during preseason.
So now is the time to get involved.
Now would be probably a great time to start making connections with local teams. That way you have plenty of time to get to know people before things get really crazy. So that way you can kind of build that bond before you go in and just kind of jump into the hectic nature of build season.
But mentoring is only one way. There's also the judging, which is a little easier because you can often, and volunteering the day of, because you can just kind of drop in without a whole lot of preparation.
Yeah. So generally, if you want to volunteer at competitions, you can find competition lists on First, and then you can go through and contact whatever organization in your region is hosting the event, and they welcome all volunteers, because they need all hands on deck to be able to maintain the field, replace field elements, reset them, as well as other kind of upkeep actions during the competition, like manning the food court and the concessions, as well as going around help cleaning or unpacking the fields.
Yeah, and sometimes it's just fetch and carry and hang out with the judges and ask them what they're doing and taking notes for them.
Yeah.
They welcome that one time.
They welcome all people to help. Generally judging is more for people who've been around FRC for a number of years, because obviously they need to know what's going on and how to judge. So, yes. But if you spend time around it, you can hopefully be able to work into being judging after you spend an amount of time helping out and getting to know things.
And how did you sign up for the robotics team?
So I signed up at my school before the call-up meeting. We have a call-up meeting. It's early first week of September. It varies a little bit, but school announcements, they had flyers. Freshman year at my high school, since I believe there's over 100 different active clubs at the high school. They have, for freshmen, they have a kind of a club show where all the clubs have a little booth, and you can walk around and see what it's all about. So that's where I first learned about TechHOUNDS, is through that, just kind of seeing them at the club and say, oh, that's cool. And I went to the call-up meeting. And then at the call-up meeting, how did they sell it to you? They say for 6 weeks you won't have to sleep and you won't get any schoolwork done. No, that's doesn't this sound like fun? That's definitely not how that'd be a bad way to pitch it. We usually let them figure it out during build season. Yeah. But no, they were generally, we display our robots, kind of if it's too crowded, we won't drive them around, but, we'll have all the lights on and all the LEDs on and just kind of, make a big show so it looks impressive. That way people kind of are attracted to it. And then we hand out flyers with like the call out date and where it's at. And hopefully people will show up after that.
I would. I want to go back to high school just so I can play with this.
No, you don't.
No, probably not. I don't think I'd survive the 6 weeks.
Yeah, it's a very stressful time, but it's a great experience for sure.
So you're a high school student. Mm-hmm. Do you do any other high school experience things? Any other clubs, sports?
I do National Honor Society at my high school. I'm a member of the National Honor Society chapter there. So that has volunteering. So you have to get mandatory hours for that. I did do the computer building club my freshman and sophomore year. So that was a volunteering club where essentially you take and refurbish computers and they give them to lesser fortunate organizations that need computing, so accessible to students.
You seem like a really nice guy.
Oh, thank you. I appreciate it. I try.
Christopher's laughing at me. It's nice. There's so many times you hear people say, the next generation's terrible. Get off my lawn, kids. And I have to admit that every time I talk to high school and college students, it's like, this is fun. You guys are cool. I want to join.
Yeah.
And so, yeah, it's really nice to hear that.
Obviously there always are those who kind of perpetuate that stereotype, but I myself do try to kind of break the perception that high schoolers or the younger generation are these kind of delinquent rebel kids that, don't really do anything that's useful to society. But I kind of try to break that a little bit in my own way.
You should still rebel. That's important. It's an important life experience. Christopher, I'm clearly getting off subject. Do you have any questions you would like to ask Derek?
So aside from FIRST and robots, do you do any electronics for yourself for fun? Or is it so much, I'm done with that, go home and I play video games?
No, I design almost every day, honestly. I do love it. A lot of times I'll just be browsing Instructables or something and, oh, that looks really cool. I really want to build that. Or this summer, a group of guys from the team, do you know about Sparkfun's automated vehicle competition?
Yes, but please explain.
Yeah, so, we decided we want to get into that. We haven't had enough robot building during the year. So let's go build a robot. We design everything ourselves. So I've been working on designing the hardware. Another friend of mine who's way more mechanically inclined than I am myself, even though I am the mechanical design lead. He designed the drivetrain and the system for that, as well as my lead programmer from last year. He's been doing some of the software. We've had some setbacks, but with the electronic hardware, I've had some issues with blowing up FETs more than I'd like.
I do that
because we had the calculated current load of like 80 amps and they don't like it. And then I had some shoot through problems. I was having shoot through problems that I couldn't figure out for a while. And
you should have gone on the amp hour because we can't help you.
Yeah. Yeah, shoot through is a pain because then I traced it. Apparently the MOSFET driver I was using died, and that's why I was shooting through. So I spent all this time, I redid the entire design, desoldered everything, put in new FETs, a new circuit layout, bodged a bunch of stuff, and then it still broke. And then I finally desoldered the MOSFET driver and it worked again. But I didn't want to replace it. It was $5 a pop. So I'm like, it can't break. It's too expensive. But it did.
Yeah. So are you going to the competition in September?
I don't think so. Due to kind of having the setbacks, it's not coming into as fruition as we wanted to. Plus the logistics of getting a couple guys all the way to Colorado and back. It's quite a haul, so we probably won't go, but we have been practicing. It's more of just a learning experience, hey, let's do this over summer and design what we can. It wasn't, originally, I don't think we intended to go, that wasn't out of the gate. We didn't exactly intend on going, but we just hey, here's design parameters, let's build something.
All right. I bet you have more things you would design if we would let you get off the microphone and go design something. Do you have anything in mind for this weekend?
I'm working on, I saw it on Instructables. It's a weather simulator. So it's like those little boxes where it pulls weather data down and then it recreates the weather in a little box. So if it's foggy, it'll use one of those ultrasonic, water mist generators to make it foggy, or uses neopixels to make thunder and speakers to make lightning and thunder. So I've kind of sent the 3 prints off to our printer at school, and hopefully that'll come. I'll have that in a week or 2.
I don't know about the weather here, but then I usually see the weather here. Sure, it'd be fun to have the weather wherever somebody I cared about was.
I mean, you could probably do that.
Yeah,
you just change the API
else.
key and your location, and you're got the weather for someone else. Although I probably wouldn't.
We change it to Andre's house and get an ice cube.
Yeah, I don't just be an ice cube all the time.
I probably wouldn't change it to California because it's always sunny, so it'd just be white, bright lights.
No, that's not true.
No, we have some nice fog sometimes. It's pretty.
That would be cool because I like it when it fogs. At least in the little simulator, it looks cool. But yeah.
All right, Derek, do you have any thoughts you'd like to leave us with?
I'd say a thought to leave everyone with would be that First is kind of, I believe Dean Kamen, who's the founder of First, said it's the best kept secret in engineering is that First, not everyone knows about it, and I highly recommend everyone to get involved, find a local team, go in and help them out. If you have a son or daughter or a niece or nephew, see if their high school or middle school or elementary school has a First, has something related to First, and hopefully you can get them involved in that because it's an amazing opportunity, and I think everyone should get involved with First.
Our guest has been Derek Fronek, robotics design lead of his FRC team, TechHOUNDS. Derek is also a senior at Carmel High School in Indiana. Of course, there will be numerous links in the show notes if you want to know more. Check them out in your podcast app or on embedded.fm. Thank you to Christopher for producing and co-hosting, and thank you for listening. You can contact us, show at embedded.fm, or hit the contact link on embedded.fm. And now a quote to leave you with from J.M. Barrie of Peter Pan. All the world is made of faith and trust and pixie dust. Embedded is an independently produced radio show that focuses on the many aspects of engineering. It is a production of Logical Elegance, an embedded software consulting company in California. If there are advertisements in the show, we did not put them there and do not receive money from them. At this time, our sponsors are Logical Elegance and listeners like you.